Okay, what you have here is a drawing similar to the one you have in your notebook that represents the question we were starting to solve the last class. I'm going to summarize a little bit for you what we have found and what we have discussed. So, the ball that would be here, obviously, is kicked with an angle of 40 degrees and a velocity, an initial velocity in that direction of 20 meters per second. And this is the trajectory that the ball will follow. Now, one thing we said is that this vector of 20 meters per second is not entirely horizontal, is not entirely vertical, but it has a direction in between those two. In this case, that direction is given by the 40 degrees. And that means that the 20 meters per second will be divided into an x component and a y component. That means that part of this 20 will go in this axis and some other part of those 20 will go into the y-axis. Why is that important? Why do we need those two values? Because with the value of velocity of the x-axis, we will be able to know how far it goes. How far it travels depends on how fast it goes in this direction. And with the velocity in the y-axis, with the value of the y component, we will find how high it goes, right? So each one of those two velocities will help you determine some values on the trajectory, either horizontal or vertical. Now, how do we find those values? We said that we just use what we learned about vector components. We have a vector here, the red one, and we have its magnitude 20 and its angle 40 degrees. By using those two values, using sine and cosine, we can find the piece of the vector that goes in the x-axis and in the y-axis. So for the x-axis, because the angle is down here, we're going to use cosine. So that's why I wrote here that the x component of the velocity, vx, is equal to 20, the magnitude, times the cosine of the angle, which in this case is 40 degrees. So, as always, I multiply magnitude times cosine of the angle to find the x component. When you do that, you get like 15.3, but we can round it to 15. Now, to find the piece of the velocity that goes in the y-axis, we use, instead of cosine, we use sine. And we use it in the same way. 20, again, which is the magnitude of the total vector, times the sine of the angle, which in this case, as I said, is 40 degrees. You do that and you get 13 meters per second. So these two values will be used in the equations. Before we move on to actually solving the rest of the question, I need you to be aware of this. What we found here is that Vx is 13 meters per second, so that is the initial value of velocity that this object has in this direction. And, sorry, it's not 13, it's 15. And in the y-axis, Vy, we have 13 meters per second. So, as this ball moves up, those values may or not change. What you're going to find, and this is something that we already discussed, is that in the x-axis, in the x direction, in the horizontal direction, the ball will always have 15 meters per second. So when you look at the velocity of the x-axis of the ball, it will always be 15 meters per second. Why is it constant? Because there is nothing that stops the ball from moving on, right? There is no, we're not considering air resistance, there's nothing here that would stop or make this ball slow down in the horizontal direction. Now that means that in the x-axis, in the horizontal direction, I'm gonna write it here. In the horizontal direction, we're going to be dealing with motion with constant velocity. And what is that constant velocity? That constant velocity is 15. It doesn't matter where you look at it, even if it's down here, when it hits the ground, it will still have the velocity 15 meters per second. Now, what happens in the y-axis? Because the y-axis is the axis along which the gravity is acting, then this 13 will not always be 13, right? We know that this thing doesn't move up and up and up constantly, but it stops at some point. It stops right here. It stops going up. It never stops going forward. So this 13 will be reduced at some point, right? Because this is the gravity is making it smaller. This velocity will not be 13, but will probably be, I don't know, 8 or 5. I'm not gonna write the number because I'm not sure. But what I'm sure is that this value, the magnitude of this arrow will be smaller here than here. What is going to happen up here in the maximum point? The velocity in the y-axis will be 0, right? So I'm just gonna write it like this. I'm gonna say that the vertical velocity is 0, just here, right? Because that's the point where the ball stops going up. Now, when it continues moving downwards, the velocity will start increasing, but in the opposite direction. So here, for example, you will find a velocity pointing downwards that it's bigger than this one, right? Because it's like below that point, but it's smaller than this one because it's not going that fast yet. So as you can see, in the vertical axis the velocity is 0, but then it increases and then it increases more when it hits the ground. Right when it hits the ground, not after it stops, but right when it hits this point, it will have negative 13, because that's the initial value that it had. And we know that when things go up, they lose their velocity. That's why it is going from 13 to 0 here. But when they come back down, they regain that velocity. So the velocity here would be 0, and the velocity here would be the 13 that it lost, but in the opposite direction. That's why we have a negative 13. And if we find the magnitude of the whole vector of velocity when it hits the ground, here it should be what? It should be 20 meters per second, right? Because it's the same value that it had. So it lost a little bit of that, but when it gets down here, it regains that velocity. Now, I said here that in the horizontal axis, we're going to analyze everything in the horizontal axis with motion with constant velocity. And in the same way, I'm going to say that in the vertical axis, we're going to have basically suvat, right? And specifically, we're going to have free fall, because in the vertical axis, what happens if you look at this trajectory is that the ball went up and down, and going up and down is the classic example of free fall, when you throw something up in the air and it comes back to your hand. So that will be suvat. And in the horizontal axis, right, we will have motion with constant velocity, because that velocity, which is 15 in this case, never changes. And when you combine those two types of motion, this horizontal motion with that vertical motion up and down, what you get is this trajectory here that looks curved. So this is what we did, and I just need you to keep those things in mind. Horizontal motion is constant velocity, vertical motion is free fall. Okay, so this is what we have, right? Horizontal motion, vertical motion. We're going to try and put together everything we know so we can decide how we're going to find the things that we need to find. Remember, the questions are the flight time, so the total times that it takes to hit the ground again, the maximum height that the ball reaches, and the range that it covers, the the horizontal distance. So in the horizontal direction we have motion with constant velocity, and there we only have one equation: displacement equals velocity times time. So we have just those three variables. It's an easy equation, very easy. If we have enough information, we can surely solve with this equation very easily. So let's see if we know. We have the displacement, the velocity, and the time. Do we know the displacement horizontally? Remember, we're thinking horizontally. Horizontally, we don't know how much the ball moves, right? In this motion, we don't know this distance, or I don't know, this distance to the maximum height. We don't know any of the displacements along the x-axis. And actually, that's one of the things that we're going to need to find. So we don't know this, right? We don't know the displacement in the horizontal axis. Do we know the vertical do we know the horizontal velocity? Do we know how fast it is moving along the x-axis? Actually, we do, because remember that we just found the components of the vector. We said that the y component was 13 and the x component was 15. So 15 meters per second is the velocity that the object will always have in the x-axis. Now the time is the only variable that will connect the two axes. So time here and time there will be the same. But do we know the time? Do we know how long the whole trip takes? Or do we know half of the time? We don't know that. So in this horizontal axis, although we have the easiest equation, in this particular problem, we only have the velocity. We don't have the displacement, we don't have the time. I need you to look at or keep this in mind. In the horizontal axis, we don't talk about initial velocity and final velocity because it's constant velocity. So in the horizontal axis, we just talk about velocity, right? So we only know that, and with only that value, there's no way we can find the displacement or the time. Now, let's look at the vertical direction. In the vertical direction, we're talking about what happens along this axis, along the y-axis, up and down. Do we know up and down how far this goes? Do we know this distance, which would be the maximum height? We don't know it. Actually, we need to find that. So I'm gonna just write an X here because we don't know it. Do we know the initial velocity? Do we know how fast this thing was moving? We know that it was 20 here and that it was 15 here, and we also know that this was 13. So we know this value, we know the initial velocity, and that initial velocity was 13 meters per second. This velocity will change for every point because this is an accelerated motion, but at least we know the initial velocity. Do we know the final velocity? Well, that depends on what do we mean by final. If final is this point, yes, we know, because if it has 13 here, it will have negative 13 here, right? But if I say that the final is this point, we don't know how fast it is moving. So this will depend on what we say it's the final point of the analysis. If I just want to analyze from this point to this point, I know that the velocity up here will be 0, right? So I'm just gonna write, because it's a very useful thing to use, I'm just gonna write that the final velocity is 0 here, but I'm going to clarify that is just at the top, right? The only point where the velocity is 0 is this point here. But that is very useful because if I know how much time this ball takes to come to this point, I know that if it takes, let's say, 2 seconds in this trip up to this point, it will take also 2 seconds on its way down, because what you take to go up is what you take to go down. So it could be useful to have that. Do we know the acceleration? Yes, because in the vertical direction, again, vertical direction, the acceleration is the acceleration that makes this object stop going up. And what is that acceleration, or what is that force that stops the object from moving up and up? Is gravity, and the acceleration we know is negative 9.8 meters per squared second. And do we know the time? Well, we don't, so this is what we have. Let me just erase this. So look at the information we have. From the horizontal axis we know just the velocity, and that's it. From the vertical axis we know the initial velocity, 13. We know the final velocity at the top. We know the acceleration, which is always going to be negative 9.8 meters per square second, and we don't know the time. So let's keep that in mind, and let's hit question A. Question A was the flight time. So the flight time is something that we could find using either the horizontal equation, because it has time, or the vertical equations, which also have time. But as you can see, I cannot use this one, right? Because I only have one thing, and I would need the others to actually be able to find the answer to the time. So we're not going to work with this. Let's look at the vertical direction. We have a lot more information. So is there any equation that would allow us to find the time, which is what we want, knowing the acceleration, the initial velocity, and the final velocity at the top? Yes, there is one equation that is going to help us do that. So let's see how we do it. Okay, here we have the Suvat equations, right? The 4 equations. We're going to work with this because we just decided that we have more information in the vertical axis to work with. So it's the right thing to do. We need to find the time. So we could use either this one, or this one. Now, what do we have? We have the acceleration. So we need an equation that has the acceleration. That would only be this one or this one, so we cannot use this equation, right? Because it doesn't have the acceleration, and it's one of the things that I have. We don't have the displacement, right? So I cannot use any equation that has the displacement, so I'm not going to use this one, and I'm not going to use this one also. So the only equation that would allow me to find the time is the third equation, because we know the final velocity, which at the top is 0. We know the initial velocity, vertical initial velocity, which is 13, we found by using sine. We know the acceleration, right? And we need to find the time, so we can use this equation down here to solve for the time. Okay, so let's put the values in the equation. I need you to remember before we put the values there that here we're going to be talking about the initial velocity here, which is 13, right? The initial velocity. And the final velocity, we're going to consider that final velocity here, which is 0. That means that when we find the time, we're not going to find the whole time. We're just going to find the time that it takes to go to this point, and we're missing the other half. But we know that if it takes 2 seconds to go up, it takes 2 seconds to go down, so the whole time would be 4. So I'm just gonna put the values here. The velocity, the final velocity is 0 at the top. That is equal to the initial velocity, which is 13, plus the acceleration, or sorry, minus, because it's a negative acceleration, minus the acceleration times t. So I need to just solve for the time. Remember, you cannot do this 13 minus 9.8 first, because there's a multiplication here, and you cannot do this one first. So what you do is you leave this alone, you don't move it, you don't touch it, but you just need to get the 13 to the other side. So I'm going to subtract 13 here and here. 0 minus 13 is negative 13, then this 13 cancels and I get minus 9.8t. And now, because the negative 9.8 is multiplying the t, I just divide over negative 9.8, divide over negative 9.8. The 9.8 cancels here, so I get that the time will be 13, negative 13 divided negative 9.8. That will be my time. And if I do that in the calculator, 13 divided by 9.8, I will get 1.3 seconds. So 1.3 seconds is the time. What time is this? This is the time to go up, right? This is the time that the ball takes to this point of the trajectory. So it's not 2, it's not 2, it's 1.3 seconds, right? And because I want the flight time, I'm just going to represent that with TF, flight time. The flight time would be 1.3 seconds times 2, right? Why times 2? Again, because it takes 1.3 seconds to do this, and it will take 1.3 seconds to do that. So the whole thing, the whole flight time of a projectile, or of the ball in this case, will be 2.6 seconds, and that is our first final answer. So this is just a SUVAT problem, right? We just put velocity, final velocity, initial velocity, time, and we solve. It's nothing new, right? We have done this many times, because you have solved problems of how much this takes to go to its maximum point, and this is how you solve it. So how can we do this? Because we have separated the horizontal from the vertical. And when we look at the vertical information, we know that we have enough to find the time, so we do it, right? Sometimes you will have enough information in the horizontal axis to find the time, so you do it with that one. But in this particular one, the information that we had in the vertical axis was enough to find the time, so we did it. Just remember that we found half of the time, which is the one that takes to go up, and then we multiply it by 2, because the final velocity that we said was 0, and that happens just at the top, so the time would be that one. Okay, very good. Let's go with the next question. Okay, before we move on, please take notes of what we just did. Some of you probably already had that, because I know with one of the classes we solved that, but I don't know if everyone took complete notes. So for part A, make sure you have those notes in your notebook. If you need to stop now and go back and take the notes, do it, because you're gonna need that. Okay, let's talk about the second question. The second question was the maximum height, right? The maximum height is obviously the height that the ball gets when it gets to its maximum point. This is supposed to be symmetric, so it will be something like this. This is what we're trying to find, this maximum height here. So the height is something that happens in the vertical direction, right? The height doesn't happen in the horizontal direction. So because the height is something that belongs to the vertical direction, we have to use the vertical equation, the vertical axis equations. Even if we had every piece of information, we cannot use this easy equation to find the maximum height, because this is a horizontal axis equation and the height belongs to the vertical axis, so we need to use this one. So from the Suvat equations, right, we need to select one that lets us find the height, and in vertical terms, the height refers to the displacement, right? How high it goes is the same as what is its displacement in the vertical axis. So what we're trying to find is the displacement. We already have the initial velocity. We know that the velocity at the top of the trajectory is 0, that the acceleration is 9.8, negative 9.8, and the time to the top is 1.3. I'm not using here the whole time, because that whole time would be the time to go back to the ground, and that's not the time I need. If I want to find the maximum height, right, if I want to find this point, I need to use the time that belongs to this particular position, and the time at this point is 1.3 seconds, right? So if you look at the Suvat equations, you're going to see that there's one equation that lets you find, actually there's more than one equation that will allow you to find the displacement or the maximum height. Here I'm going to use this equation just because I know how much you hate it, which you shouldn't, right? This equation can be a very good friend of yours, but you just don't let it, so give it a chance. I'm going to use this equation to find the displacement, right? Why? Because I have everything. I have the final velocity, which in this case is 0, so 0 squared equals to initial velocity 13 squared plus 2 times the acceleration, which is negative 9.8, times the displacement. This displacement, because I just said here that the velocity, the final velocity was 0, that means that I'm referring to this point. So this displacement will be the vertical displacement in that point, so that is precisely what I need, the maximum height. So this is very easy to solve. So I'm just going to solve. 0 squared is 0, 13 squared is 169. I can solve this. I can do this multiplication. 2 times negative 9.8 is 6. Sorry, 2 times 9.8 is 19.6. Sorry, I should have known that. So it's negative 19.6 times s, right? This sign is negative because the result of positive 2 times negative 9.8 is negative 19.6. So here again, I cannot do this operation 169 minus 19.6 because there's a multiplication here. So I need to first get rid of this. So I'm going to subtract 169 here and 169 here. 0 minus 169 is negative 169. These two will cancel. This is equal to negative 19.6 times s. Now what do I do with this? I just, because this negative 9.6 is multiplying the x, I just divide it. So 19.6 divide here, and I divide here 19.6. These two cancel, and when I do this operation, 169, well, the negative sign will cancel, so I'm just gonna do the positive division. 169 divided 19.6 is 8.6, so 8.6 is the displacement. And what are the units of the displacement? You have 3 seconds to remember. 1, 2, and 3 meters. Okay, so the displacement is 8.6 meters. Now, you could have found this same answer using this equation, u plus v over 2 times t, which I know you love because it's easy to use. So you just do 13 plus 0 divided 2 times 1.3 and you get exactly the same number. Or you could have solved it using also this one that you don't like so much, ut plus at squared over 2, but you know the velocity, you know the time, you know the acceleration, the time here again, so you would have obtained exactly the same value. Why did I use this one? Well, I know I said it was because you hate it, but actually there's another reason. I used this equation because sometimes the only question that you will get is find the maximum height. So this is a process that you can use to find the maximum height without knowing the time. If you see, we never used time here, so by using this equation you could find the maximum height without knowing the time. Now if they ask you the time, you can first find the time and then use any of these 2 equations to find the maximum height. But if you don't need to find the time, finding it first will take from you some time that could be used doing something else. So it's useful always to know how to use this equation, because I might just tell you find maximum height, and this is a faster way of doing it. We're gonna just now move to the last question. Okay, the last question is part C is find the range of the motion. And the range, remember, if the trajectory is like this, the range is this whole distance from this point here to that point over there. So we need to find that whole distance. That distance will be related to the horizontal direction, right? That means good news for some of you probably, because we don't have to do subat, so we don't need to deal with those equations because it's a horizontal thing. We're going to find it with the horizontal only equation that we have, which is this one. So let's see how we do it. We just found that the maximum height was 8.6, so this displacement, this vertical displacement, is obviously at the top, right? That's the displacement at that point, it's the maximum height. And this time here is also, I didn't write it, the time to go to the top, and this velocity is just at the top also. So I just need to clarify that because we're going to be using partially that information now. So the range is a horizontal variable. That means that we're going to use the only equation that we have, S equals V times T. Now here, right, we still don't know the time, not because we don't have it actually, because we already found it, but because we haven't related this to that. So I'm trying to find the range, so I'm trying to find this whole displacement, right? I'm going to find S, the displacement from this point to that point. That means that I'm going to find this in the equation. To do that, I need to multiply the velocity in the x-axis, right? The velocity will no longer be 13. The velocity now will be 15, because that is how fast it moves in the horizontal direction. So if I'm dealing with this equation, I'm dealing with this velocity. So we know the velocity and the time. So what is the time, right? Take a few seconds to think about that. What time would you put here? Okay, that was an awkward silence. Probably you already have the answer, and the answer is the following, because I want to find the time from this point to that point. I need to use the time that it takes to go from this point to that point. And how do we call that? We call that the flight time. Is that 1.3? I hope you said no, because 1.3 is the time to the top. So the time that we're going to use here will be 2.6, which is the flight time. Remember, it was 1.3 going up and 1.3 going down, and 1.3 plus 1.3 is 2.6. So we're using 2.6 seconds, which is the time that it takes to cover the whole distance. And I'm using that whole time because I want this whole distance. Now I'm just going to use it. It's very simple. Displacement will be velocity, again, horizontal velocity, never vertical velocity, times the time. And what is the time? The time from this place to that place, which is the whole flight time, which is 2.6 seconds. So I just do it in my calculator. 15 times 2.6, that's 39. So the displacement will be 39, and the units of displacement are 3, 2, 1 meters. Okay, so this ball that was kicked with an angle of 40 degrees at a velocity of 20 meters per second took 2.6 seconds to do the whole trip from this point to that point. It traveled a distance of 39 meters and it reached a maximum height of 8.6 meters, right? How did we find that? Again, by separating. We separate vertical from horizontal and we analyze the information. It's nothing new because we already know how to use this equation. It's nothing new because we already had studied how to use the Subat equations. We're just putting it together in a different way. Okay, so what now? Well, you already know how to do that. Now, a couple of things. The first one, you need to collect from me, I'm gonna give it to you as you go out of the room, a worksheet that has questions about projectile motion, right? The idea is that you solve those questions before we have a starter next day 1, which is going to be on February the 6th, right? So you have from today till this day to finish the worksheet that I'm gonna give you, and if you can't, because you're finding because you're struggling with it, just let me know. Come to tutorials, ask me, and I will let you. I'm gonna help you to solve that worksheet. It's a list of, like, I don't know, 6 problems about projectile motion, but I'm sure you're gonna solve that. Then on February the 6th, we're gonna have a starter about that, right? I'm just gonna give you one of those questions. I'm gonna ask you to find, I don't know, flight time, range, time, velocity, whatever I'm gonna ask you to find. And then the last step for this will be on February 16. We're gonna have an exam that will cover from vectors and everything related to projectile motion. I'm doing this because I want you to write down these 2 dates so you remember, right? This is going to be in Phidias. So you're going to have a starter here, a big starter, so you have to come prepared for that. That's why I'm giving you this worksheet. And then you're going to have an exam on February the 18th, right? Part of this exam will be also points for stutter, right? So we're gonna have a stutter here, we're gonna have a stutter here, and this worksheet will also give you points for the stutter. So you want to do this because it's going to give you points for the stutter. You want to do this because, well, you have to, because you're going to be sitting down to do it. And obviously you want to do this right, these two things, because this is going to give you points for the stutter. This is going to be an exam, plus it's going to give you points. So I want you to get, I want you to have a really nice stutter grade plus a really nice grade in your exam. So use this to make sure you get there. Okay, that's it. Just let me know the questions that you have, and as always, I hope you enjoyed this because it took me a long time to do it.